You say
Oh, it's a good point. We didn't differentiate whether it's Lord of the Rings or the Tolkien.
Oh boy.
Legendarium.
We're just immediately coming in hot with Lord of the Rings. Immediately. Right out the gate.
I can't find the link.
I need to look at this just for a minute. Well, no,
There
we
we
can
go.
share it. I just...
Don't you have your own?
Yeah, but
Oh.
I had to type out... I typed out my thing because I needed to read it.
I got this so that I don't have to share.
But you already had one.
Yeah,
And then I have my own.
This way I get to...
Yeah, we're already live.
You didn't tell me that.
Well, when I said... it was implied when I was like, and we're coming in
okay.
hot with the
not-
Lord of the Rings references. Anyway, happy Easter, everybody out there.
Hey.
I
I think it's just me on there.
it's okay. We can
That's
talk
okay.
to ourselves and the ether, and
I do that quite a bit.
Yeah. So, we like to call it. I'll say I like to call it. I don't know, Zombie Jesus Day. You know.
Zombie Jesus Day is a good one. National, of course, 420 Day.
Yes. Happy 420 to everybody out there, bros.
For those who celebrate.
420 bros. Katie's on. She's trying to help my mom log into her. Oh, she got a new iPad. Oh, congrats, mom, for getting a new iPad.
Well, she doesn't. She can't hear you say that.
I know, but Katie will tell her. She's providing, I'm
right
sure,
now, she
on the phone
can't.
tech support or something to her.
You see, this is why I do not give out my phone number to your family. I don't want anybody.
Oh, her other one broke. Wow. I'm not the only one in my family that isn't a big iPad user.
Nah.
Meanwhile, we have two in the house.
I know.
And one that is just fuck the other one. The third one. Yeah.
Yeah.
I was like, why is my leg so lotiony? It's because I have a tattoo there.
Oh, yeah.
Oh.
That would
You got a
be...
new tattoo?
No. I
just keeping it hydrated.
I keep all
one
my
of his new
tattoos
ones.
hydrated as best I can.
Okay.
I got one right here at,
Nice.
at my little phaser gun.
Ray gun.
Ray gun.
It's cool. It's cool. It's the
Oh, she can
coolest
hear
tattoo.
you, so
I know.
she
It's
just
the coolest
can't
tattoo.
use chat on her iPad. So she heard you. I heard you say.
All right.
You ready?
Well, yeah, we got 12 pages of notes to get through, folks.
Yeah, we do. And Brandon's running
This
the
is
show.
it's a Brandon episode. That's how you know.
Which means I know very little about what's gonna transpire in this
Meanwhile,
episode.
I did what I was supposed to do. I read through the notes.
I'm just, carpe diem.
Did they make sense? Because I only read them through once when I was making them, but I don't know if it makes sense.
Okay. What I got to made sense. You had not added the last 3 sections.
That's at least okay. I
time-
did that this morning at least, so I know that's good.
Yeah, I think I got.
All right,
to it
well,
before you started adding stuff.
I'm sure it'll make sense while at the same time not making any sense at all. And our minds will start melting at some point.
So that's the
with
point.
The
It is
nature
420.
of this episode.
So Susanna, I talked to her this morning, and she said she wasn't going to be able to join, and she wanted to know what the topic was. And so I told her what the topic was, and then talked about chaos and that kind of stuff in the solar system and stuff like that. And I said, yeah, and Brandon wrote the notes, and he's got this one section where it's just all you got to do is just say the galaxies aren't moving fast enough. That's all you got to say. And she was like, oh, okay. You are going to tell him that, aren't you? I'm like, yeah, in the podcast.
Okay. I'm not there yet in the notes. I don't know what we're talking about yet. So other than
All right.
All right, let's do this.
some really cool shit.
Cool shit, man. Yeah, some cool shit.
All right, you want to count down? 5.
Yes, once your internet gets back. Okay, ready.
4. Oh, did we lose internet? Okay. 5.
Nope.
4. 3. We're reconnecting to OBS. It just has to take a minute to get back to stream.
All right, now countdown.
Oh my gosh. Okay, I don't know if we're back yet, but
It says successfully connected.
okay. So
It looks like we're back.
we're back. Okay.
All right,
Try this
countdown.
again.
Go.
Can you? And
Hey,
5,
folks, welcome to...
4.
Oh, goddamn.
Well, it's just okay. Just go.
Well, now it's ruined.
No, just go.
Hey, folks. Welcome back for another exciting edition of Cosmos with Cosmos. I'm Brandon.
I'm Liz.
I'm Mike.
And we're just starting this off great, aren't we?
That's great. It's so much fun. Fun.
You might say this introduction is a little chaotic.
Oh, well, then it goes.
We'll find the structure.
Oh, well done.
I bet you. No, look at us taking it home. Yeah, so we're talking about order from chaos and structure today within the universe. My mind got blown during this research, so we're going to see how today goes on 420 of all times.
Woo!
Okay, so before we dive into it, Mike, what you drinking?
The Monkey Head Chaos.
Oh.
Monkey Head Chaos.
Yeah, so it is a Monkey Head banana bourbon with peach simple syrup, orange bitters, and to add a little chaos to it. I haven't tasted it, so I don't know what it's going to be like.
Ooh.
99 banana
liqueur.
So 99 proof banana liqueur.
Oh my God.
So cheers, everybody. We'll see how this
Mike's
goes.
Mike's gonna ask me chaos later on today.
Yeah.
All right, Liz, what about you?
All right.
Yeah. Good.
I have the Great Attractor because alcohol makes everything go down a lot easier. Makes everything a lot better.
Cool.
But we'll find out more about the Great Attractor later. And it's basically a peach whiskey sour with some cinnamon on top.
That's not a zone I want to avoid. All right. Another good reference. Just stay tuned, folks.
What are you drinking?
All right. I am drinking Ungoliath Shadow.
Oh.
So, for those of you who do not know, I hope everyone does, which is the case. Ungoliath is the mother of Shelob, the great spider in Lord of the Rings and Return of the King. And Ungoliath was really the only being that Morgoth was truly afraid of.
It's a spider, of course.
Yeah. So Ungoliath, being this massive, terrifying spider, of course, creates webs of darkness. And so we will see some cosmic webs later on.
Yes. I like it.
Cool.
Yeah,
Right.
So with that terrible segue, don't forget to follow us on all the things. Instagram, Blue Sky, Cosmos, the other place in freaking Cosmos. If you have iTunes, wherever you get your podcasts, rate us, follow us. That way more people can listen to our sciencey shenanigans.
I like that.
And then don't forget to follow us in The Hangover after this episode, where we'll talk about God knows what.
Oh, yeah. Who knows? It could be nothing, or it could just be a wild, weird rabbit hole.
Gonna be all politics.
Yeah.
That's our second podcast. We now have, for the next 4 years, we have 2 podcasts.
All right.
The universe, politics.
And then politics.
The Hangover.
Right.
We need alcohol to survive this administration.
All right, and I know it's difficult to tell, but sometimes I do have friends, including Katie on Wildixia on Etsy.
Yay.
She is fabulous. Check out her stuff. And then, of course, we have Ron, who makes our theme song for The Hangover. The real Proctor is the real Mr. Proctor on YouTube. And, of course, our friend Jack in Council Bluffs, Iowa. You can find his stuff in the Rolling Bluffs Planetarium.com. So if you find yourself in the Council Bluffs area, give or take a couple of hundred of miles, check them out.
As one does, you know?
Yeah.
Yeah, it's the southwestern corner of Iowa. So everybody knows.
Good to know. Yeah. And, of course, we have this show. We have The Hangover, which, is, of course, is a political show, apparently. And we have The Shots, which is 5 to 15 science bits, science droplets you can check out. And they're delightful. I love listening to them. All right. So, for the show.
You're in every single one of them.
Sometimes I'm not.
That's true.
I miss quite a few. But for the show, we have some rules. If we have a puppy bark, take a drink. Counts for me too. Mr. Frodo's right next to me. I'm on location, by the way. That's why I say Mr. Frodo's with me. It was surprising for those of you
He's out
listening
in the universe
and not watching. If we make a Star Wars reference, take a drink, or a Lord of the Rings reference, take a drink. Starting now, so my drink name didn't count.
Yes.
Okay, so we're going to talk about the structure of the universe from a low level to a high level. So I thought this was a great time to reminisce about our old friend, Major Photon.
Major Photon, yeah.
Remember Major Photon? Do you remember when we launched him, Liz? I know Mike has already looked at the notes.
2021?
2020.
2020?
March 22nd.
Oh, man. I knew it was somewhere pandemic-y.
Yeah, as it was getting going, at 2:26 p.m. Central Time. That was 1,854 days ago. So major photon is a photon that we hypothetically launch from the sun. And during that whole episode, we would check in on major photon. Oh, he's passing Mercury. Oh, he's passing Mars, passing Jupiter in the Hangover and Saturn. That was a good time. But once in a while, we like to check in on major photon and figure out where he's at. Is he past Pluto? Is he past the asteroid belt, the Oort cloud? Where is he? Yes. My goodness. Mike, that's a really big number in miles.
100,000 million billion. 29.8 trillion miles.
Wow.
Trillion miles away. That is 5.07 light years from Earth. And if you were to
unfathomable.
And if you were to lay out a path from the sun to where major photon currently is, how many Skittles is that?
100,000 million billion trillion. 4,003.6 trillion Skittles. What's after a trillion? Gazillion?
Oh, nope. That's a good question.
I don't know what's after a trillion.
Is it a gazillion?
Oh, is that a real word? Or is that just something kids say when they don't know monies and they think it's a lot of money?
$1 gazillion.
That's why I say it's 4,003.6 trillion miles.
That would be an uncomfortably long Rent song. 4,300 trillion, 600 billion, 500 million Skittles. Anyway, so a major photon has comfortably passed our nearest star, Alpha Centauri, and later on this year will be passing Barnard Star, 5.9 light years from Earth. Wow. So we're getting into it now. We are in the interstellar medium, passing stars. We are Star Trekking.
That's awesome. That's exciting.
So like around January or February of next year.
Ooh.
Wow,
Nice.
We'll just pass it. Woo. And then we're on to the next one.
Oh, man.
Cool.
All right. So with Major Photon out there, podcast showtime. So let's think really quick about structure and order. And really quickly, what is it? So what I always thought, like, you see structure, you see order, you just kind of figure out that's what it is. Things look like they're in order. Look at like a flock of flying birds, ants marching in a line.
Yeah, mighty ducks.
Like the arms of a hurricane. It's structured and it's ordered. So it's like pornography. You know it when you see it, right?
It's literally in the notes.
That's exactly what I thought of. Because it turns out there's like a wild physics science definition of what order actually is, and it involves a lot of entropy and going from chaos to order and losing energy. It was wild. So I'm going to sum it up as the predictability and stability of a system's behavior over time. So if a system is stable and at least somewhat predictable, you can say it has an order and a structure to it. Okay. Does that kind of make sense?
Yeah.
All right, sure. Yeah.
You agree with that, Fancy Physics Man?
Yeah, that works.
Okay, cool.
All right, so we can talk about the structure of the double helix of DNA or atoms, electrons, all those have structure to them, but that involves...
The real Mr. Proctor
Mr. Proctor's here! Excellent. But that particle physics involves really smart things, and I am not that smart. I like big things, like planetary systems. So.
Fair.
I think that the idea of structure is a very temporary thing. So you can't predict the structure of something well off into the distance.
Right.
It's a very local time kind of thing. Mm-hmm. Now,
and that's
local time is very
relative.
Relative. But we're talking in human lifetimes. It could be very long time.
Yeah.
Like generations upon generations is still not enough to break down some of these structures.
Yeah.
So if we look at the planetary system, let's just look at the Earth and the Moon, for example.
Okay.
So at this scale, you have the berry center, which is one of my favorite things.
Berries.
So berry center, but it's not the center of like a blueberry. Although it could be. If you look at two blueberries apart from each other, you can figure out their berry center.
The berry center of the berries.
Ooh, we have to go deeper. So what this means is every object has a center of mass, right? So it's kind of like when you're playing football or rugby. You get low and you drop your center of mass, so it's more difficult to knock you down. And in this case, it's the exact center of all the mass of the object. So the Earth, for example,
system.
has
of the system.
Of the system, right?
That system could be just Earth, which it has a center of mass. That system could be the Earth and the Moon, which has a different center of mass.
Right, right.
So, yeah.
Yeah, so the Earth, for example, just that one object, has a mass of 5.9 times 10 to the 24th kilograms, which is real heavy. So given such a large mass, you would expect the center of it to be at the very center, the core of the Earth. That's why the planet's round, after all. The mass of the object's trying to get down to the center of mass. But you would be mistaken, because we have the Moon. We have the second object, which was right, Mac. What? Why are we taking?
Well, yeah, because in the notes, in the notes, you have the Lord of the Rings reference.
Oh.
Wait, where?
But you would be mistaken.
For another mass was made.
Oh, that's what for another mass was made. Damn it. I even made a big deal about that last night, and I forgot about it.
Meanwhile, when you said the Earth mass, I almost went, almost as massive as I am.
Oh, very nice.
Okay, no, we're drinking to that one, at least, because that was beautiful.
A very good mass.
So that's the Earth, 10 to the 24th kilograms. The Moon has a mass of 10 to 22nd kilograms, much smaller. So at this size, the mass of the Moon is still impacting the very center of these two objects. So it's no longer in the very center of the Earth.
Oh, it's out a little bit.
Yeah, it's just out. Now it's so comfortably inside of the Earth.
It's just a little...
Just a little outie.
A little off.
A quick. This is I don't know if this is answerable. But like the very center, would it be considered like a point or like a range?
It's like a fulcrum, actually. Like if you're on the sea salt, a sea salt. What's that called again?
A teeter tot. A seesaw.
A seesaw. Thank you. Yeah, seesaw. So the middle is kind of that very center of where the even object is. Should they be even?
Right. It's also what they orbit around. So technically, the Moon does not orbit the Earth. Yeah. It orbits that very center, and the Earth does the same thing. Yeah. So it's just that our little circle that we make is much smaller than the Moon's.
Yeah. So you can quantify this out and figure out how much gravitational force is impacting the Moon and the Earth. You can also use that same equation to figure out how much gravity is between you and another object. So we have Newton's law of universal gravity. F equals G, m1 minus m2 over r squared.
Yeah.
So that means you can quantify
Wait a minute, what do all these little letters mean?
We're about to find... Yeah, so...
Numbers. The letters are numbers the whole time.
They are numbers, yes.
So it's gravity, the mass 1, so the mass of the first object, and the mass of the second object divided by, I believe it's the radius squared. So for example...
Distance between the two.
Distance, yeah. Thank you. So for example, given my mass, let's call it 180 pounds, and Mr. Frodo's mass, which is 30 pounds, and our distance, which is 10 feet, if you plug all that into the equation, that gives us a 1.79 negative 9th gravitational force.
Oh.
Yeah, so, we're pulling in each other's heartstrings, literally. So if we... What?
No, nothing. Continue.
So if we apply that same principle to the Earth and Moon, we find the center of gravity is not at the center of the Earth, but it's 5,000 kilometers from the center of the Earth instead.
What's that in miles?
3,200-ish?
Yeah, 3,200.
Okay. All right.
Yeah. Look at me doing quick math, I think.
Okay.
So you can make the same calculations for every artificial satellite orbiting the Earth, including the Hubble, James Webb International Space Station, and every object's very center is still very close to the center of the Earth. And so that's kind of creating the constant structure in these planetary systems. And that same thing is present in every planet in the solar system. Jupiter, all its moons, very center inside Jupiter. Mars, Phobos, Deimos, inside of Mars. So yeah, that's the structure.
Just because our moon just happens to be a little bit bigger than it would be if it was a natural satellite.
And I think if the very center is outside the planet, it should be a binary planet. I think that's my definition.
Okay. Right. Like Pluto and Charon.
And yeah.
Charon?
I just call it Charon. Okay. Yeah. Or Karen? I don't know what to call it. Anyway.
I don't know if you can call it a binary planet. No, I'm not saying Pluto specifically for this. I'm just saying
Fight,
that in general, the barycenter is. It depends on what the two objects are. If they're asteroids, you can't call that a
Oh no,
planet.
no, no. I meant planet-sized objects. I'm not
okay.
saying like Ida and Dactyl, for example. I'm not about to call those asteroids moons just because the barycenter is probably outside of. Is Dactyl the big one? I don't remember.
Well, yes, outside
know.
of both of them.
Okay. So yeah, a planet-sized object that is round has another object. Yeah, so it's what I call binary. So that's the structure of planetary objects. If we go a step outside of planetary objects, let's look at solar systems. So the solar system structure adheres to the same rules. You know, it's bound by gravity still, but the constraints at this size kind of begin to change a little bit. So the Earth and the Moon are only 248,000 miles away from each other. However, the solar system is entirely different. From the sun to the heliopause, where the sun's magnetic influence becomes less than the, well, not magnetic influence.
Yeah. Well, the solar wind.
Solar wind, thank you. Becomes less than the influence of the interstellar wind, is 11 billion miles.
I mean,
so 250,000 to 11 billion.
It's a big place. We got lots of good land in this universe.
So that's going from the Earth to the Moon 44,300 times.
Wow.
So is a lot. It is a big place. So not only are these distances far greater, the masses are vastly increased as well. So the solar system's total mass is approximately 1.0014 solar masses, which means 86% of everything is the sun.
Yeah.
So all the planets, asteroids, comets, telescopes, all the Jackies, Frodos, all the round Proctors are 0.14% of the solar system. But at this scale, the center of the solar system, unlike the Earth and the Moon, are not at the center of the sun. So the barycenter doesn't really, matter that much. Of course, it still matters, but it's this very difference. So if we look at, we have a nice little diagram. Over the last 50 years, the barycenter has ranged from inside the sun. Has ranged from inside the sun to far outside, back in again, outside. So it's wandering around. It's never very far from the sun.
So it's a wandering berry.
It's a wandering berry.
It's like a little berry with legs, just walking around.
Yeah. Don't mind him. It's just wandering berry. He's just gonna wander.
Sorry, Frodo just sat down at the staircase and just looked at me. It's adorable.
Oh.
Well, currently it is outside the sun.
Currently, it's outside the sun.
Yep.
Here, I'll try to get this to show up. Brandon didn't get me pictures in time or think about it in time for me to build pictures in.
So really, I put these pictures in here just for us so we can talk about it if we wanted to. Hey, there's the barycenter. Look at us go.
Okay.
So the barycenter in the solar system scale isn't that important. But as far as the structure and the order is concerned, as long as it is stable and predictable, right? To an extent.
Yeah. So that's, it's going to be a little while when the sun starts to, get a little big.
A little bloated.
Like me after Thanksgiving.
Yeah.
But Mike had touched on this earlier. There is this neat thing called Lyapunov time.
What? Come again?
Lyapunov time. Say it with conviction. Lyapunov time.
Lapunov?
Time.
Lapunov time.
Yeah. So this is the limit of when a structured system becomes chaotic or like unknowable. So at some point, even like the most refined orbits become unknowable after an amount of time. So for example, we have the moon Hyperion of Saturn. And if you can remember, Hyperion's the moon that looks like a giant sponge potato.
Oh yes, okay, yes,
Yeah,
yes,
an elongated porous rock.
Yes.
However, we can only know how it will rotate just 36 days in advance. On day 37, 38, 39, it becomes too chaotic, and we don't know how it will rotate.
Really? Oh, interesting.
Yeah, I thought that was neat. So that same principle can be extended to the solar system. So even though we can, group asteroids into this group or that group and planetary orbits into a nice, neat order, they all break down given a long enough time frame. In the case of the planets, the Lyapunov time, has a range of 2 to 230 million years. Kind of depends on a variety of things. Mike has something to say.
Well, I was going to say, I think we ought to say why we cannot.
Yeah.
And it's because, but also, it's not like the Earth's orbit is going to change
degrade over
a lot.
No,
we're not saying
we're not gonna
that.
fall into the sun all
become
of
a
a
triangle. Right. Yeah.
What we're saying is,
That'd be kinda...
the Earth wobbles on its axis. You cannot predict
precession
with high precision that in 230 million years exactly which way it's going to face. There's that. But what's going on is you have all these things in the solar system. Brandon touched on it with the Berry Center pulling and tugging on things.
It's constantly
and it
changing.
changes things.
Mm-hmm.
And
yeah,
so
slowing down, speeding up.
Yeah, and so we have Newton's equation, which Brandon alluded to earlier, and from that you can make all these calculations.
Mm-hmm.
However, though, there's this little element of chaos that gets thrown into it, and that element is quite small right now, and if you wanted to make a prediction 100 years from now, you can pretty much ignore it.
You should call it like the Loki or something.
It's the Loki. It's the Loki term,
element.
really. But if you want to go much further out in larger time frames, check out our episode on time. Also, check out our episode on chaos. Didn't we have a thing on chaos?
Probably.
Or a shot on chaos? We had something on chaos. Anyway.
Remember what I did yesterday.
It becomes the chaos term becomes too large, and it really messes
chaos
things up. Monkeys things up. It monkeys things up.
There's always chaos. There always has to be chaos.
Yeah,
it's the yin and yang of the universe.
Entropy.
Let's put it this way: if you just had the sun and the Earth going around the sun, and that's all there was to the universe, like we used to think, there would be no chaotic term, because there's not anything really pulling on the Earth other than the sun.
Wow.
Okay. And so you wouldn't have Jupiter out there tugging on it, messing things up.
I wish I knew more about Dungeons and Dragons to make a reference about chaotic, because you have chaotic neutral.
Chaos,
you have, but I can't. But so I'm just somebody else. I'm leaving it to you.
I mean, the universe is chaotic neutral, right? It doesn't care. It's just.
Oh, that's true.
It's just here for the chaos.
That is true.
Yeah.
Thank you.
I just wanted to say why things were chaotic.
Yes, and just because we've been throwing this word around, entropy. Entropy is basically, imagine like every
we've been saying it a lot, and I just missed it.
Well, it's come up. I've noticed it. Okay, but just imagine it's like when you clean your room or you clean your house, and then somehow over time it gets messy again. You're like, God damn it, I gotta clean again. It's entropy. In a very simplistic nutshell, based on an example that I heard once as well.
Well, yeah, and so there's really no need to clean your room, because if I had known
this is our making the bed principle, basically. Like, whatever. Just gonna get back in it.
If I had known about entropy as a kid,
oh no, you never tell children about entropy.
Yeah, my parents would not have.
It's just gonna get dirty again anyway. Why bother?
I would have been sent to military school.
All right, so there's the solar system with its entropy and its chaos. But further out, we have the Oort cloud, which is like the leftover bits from the formation of the solar system. Well, and it's like a big old snowball.
Isn't it still
like a big old snowball?
Part of the solar system? Like it's still
it
within
is.
the...
Yeah, it's part of the solar system.
Okay.
Yeah, it's still part of the solar system. And I'm adding this because I thought this was really neat. I haven't heard too much about this. So it starts around 2,000 AUs from the sun through 5,000, or to the 5,000 AUs is when it starts, ish, more or less.
Yeah.
So it's kind of the snowball structure could potentially be disrupted by the star CwC 710. So this star has a high chance of passing within the outer Oort cloud, 100,000 AUs, and disrupting all those comets in the Oort cloud. I didn't know about that, and that was really neat.
That's
so I just wanted to add that bit. Yeah.
Yeah, so we're going to...
it's about 1.5 million years from now, I think.
Yeah, so CwC 710 is going to be sending all these comets.
So it's going to be comet meteor shower insanity. Oh, we better have if we're still around, we wish, unlikely. We better have like a good, asteroid comet defense system.
Yeah,
let's in 1.5 million years.
In 1.5 million years.
Let's get past this next 3 years, 9 months.
Okay.
Okay, let's do that. All right, so there is... So there's a bit of structure of the solar system. We have our planets, orbits, not knowable in a couple million years, but that's fine. If we step out a little bit more, not quite at the galactic level, but close to it, we have something called the local bubble.
Local bubble.
And as an aside, there's a structure before this called the local interstellar cloud, which is also known as a local fluff. And that makes me happy.
That's adorable.
There's local fluff.
The local fluff.
It's like what are those things in Star Trek?
The tribbles?
Tribbles.
Well, the
There it is.
tribbles.
I'm going to drink to the tribbles.
You don't want any trouble with your local fluff, though.
No.
So this local bubble is a region within the Orion arm of the Milky Way, which is where we live, defined by the density of hydrogen. And this region is 0.05 atoms per meters cubed, if you're curious.
I can't. I'm just going to move on.
I know.
I can't.
But this is a specific location because the density is a full tenth less than the average density of the local fluff. So it's a special, like, vaguely void-ish area. It's probably why it's called a local bubble. And we think this is occurring because of recent supernovae that have pushed out hydrogen atoms.
Oh, interesting.
So it's clearing out space. Basically, it's pushing everything away. So it's a little more void than everything else around it.
Interesting. I'm trying not to think about what's in the void.
Well, it is 0.05 atoms per cubic centimeter.
Yeah.
That's
Don't
what's in
stare
it.
into that.
Don't stare into
There's
the void.
also some stars and some
There's a couple
planets.
stars, lots of hydrogen, some
You know what's
plasma,
crazy
sure.
though is does that 0.05 atoms per cubic centimeter include stars and planets and stuff like that, or is it just interstellar?
That's a good question. I mean, you would think that they would take into account
How big is that space?
everything.
I don't know what that. I don't know.
Don't ask these questions, Liz.
I don't know what this means. These numbers. I need to be able to visualize it.
Well, for example, I
This is
think
what
in
I need.
I think just outside of our solar system, the density of space is like 1 hydrogen atom per meter.
Okay, what does that mean? Like one.
So
like
so
put
if
it
you
in
have
a.
something about this size,
Yes,
okay.
I see it.
but it's a cube.
Okay.
There's 0.05 atoms in it. So
Okay.
you would basically need like 20 by 20. So basically 20, we'll say 20 centimeters by 20 centimeters just to get 1 atom per that box. So a shoebox. If this was out
As a
in
single
space,
atom.
a shoebox.
A shoebox.
Size
Right,
box
so,
would
okay.
only have 1 atom in it.
Okay. That's
So
empty.
what we're getting at is there's a lot
very
of space in space.
There's a lot of space.
So our vacuums that we make here on Earth
Yeah.
have so much more stuff in it
Yeah.
than this region.
It's a
of
different
space.
kind of vacuum.
Well, but we call them a vacuum.
Yeah, but it's confusing, right? Because it's not the same.
no,
Because nothing's
no,
sucking
it would
anything
be the same
up.
because the vacuum.
Same idea.
Yeah, it's the same idea. I mean, we're trying to say there's nothing in this vacuum.
Oh, God. Vacuums are disgusting. Anyway.
No, not a
Okay.
vacuum cleaner. A
Oh,
A very clean vacuum, a pristine vacuum, taking the
I
air.
thought you were talking about vacuum cleaners like Dyson. And that's why I was like, it does make sense we call them vacuums because it's not the
No.
same as a vacuum.
All right, folks. So you have this shoebox area with a single atom in
Thank
it.
you.
The
That's all I
local bubble.
wanted.
From the local bubble, the local fluff, then let's go to the Orion arm. It's a little arm of the Milky Way galaxy. And then we have the Milky Way itself, which is a barred spiral galaxy.
Yes.
And we call it this type of galaxy because we have a bar in the middle and spirals. So it's a barred spiral.
Yeah, so it's more like elongated at the central point
So for those of you
bulge.
listening,
There's a picture.
Liz just
Yeah.
did like a YMCA situation explaining elongation.
I was
Well,
trying to highlight the
well, I was
central
gonna say,
bulge
you
on
can
the
put
Milky
that-
Way Lego. And
You
how
can
it's
hold that up.
elongated, whereas like a true spiral, it's just the central bulge looks more spherical than rectangular-ish, oval maybe.
So
oval.
we have a couple of components within the structure. We have the nucleus, which extends roughly 400 light years from the Milky Way center, which is where Sagittarius A star is, our supermassive black hole. Praise be. We also have the central bulge, okay, which is approximately 10,000 light years across, and it's a round structure primarily made of old gas, stars, and dust. And after that, we have
No. That's the halo. The central bulge is more.
yeah, central bulge.
the halo is older.
You can
Central
take this
bulge.
up with Harvard.
All right.
No, central bulge is older stars.
Old stars gas.
So, like, if you look at
Okay.
a picture, it's more reddish.
No, I got where you're going.
I missed the keyword old in there.
Happy 420, everybody.
After this central bulge, we have a disk. And it's both a thin and thick disk. It's 100,000 light years across and 1,000 light years thick, which is still pretty thick, but compared to 100,000, it's, like peanuts.
It's like Saturn's rings, basically.
Mm-hmm.
Like if we
Oh,
look at
yeah.
Saturn head on, we can't even really see the
Applied
rings.
directly to the forehead.
Yes, but if you tilt it, then you see more of the rings. So
Yep.
it's the same
Exactly.
principle.
Yep.
Oh, and for a really great example of this, check out either the Hubble or the James Webb Space Telescope picture of the Sombrero
It's-
Galaxy.
Yes.
Nice. Then we got the spiral arms. And the spiral arms, our solar system is in Orion. It's traveling at an average speed around the center at about 500,000 miles an hour. Shout outs. Mike would like that. And then we have a spherical component and then a massive halo that contains individual old stars and clusters of older stars, like globular clusters.
That's what I was.
There it
I was
is.
confusing the older stars with the globular clusters of old
Oh, okay.
stars.
Yeah,
So
but they're old too.
Yeah.
they are very old. Yes.
Yeah, so overall, our little quaint Milky Way galaxy, what we call home, has about 200 to 300 billion stars. And for fun, the Milky Way has a mass of 1.5 trillion solar masses, which means our entire solar system, including the Jackies, the Leias, and the Ron Proctors, comprises points. Second.
Just a lot.
0.00000000015% of the Milky Way.
Wow, that's nothing.
And that made winter.
I know.
very...
Winter was like, wait a minute, we're so small. Don't worry, you matter, Mitts.
Oh no, you matter, Mitts.
This is
Mittens?
your
Get
first
Mittens?
live appearance on the show.
Oh, you're right.
Everybody, welcome
Mitts.
Winter.
Did Indiana make an appearance and just bite him on the tail or something?
No,
Who
no, never did.
knows?
After 6 years, Winter finally showed up.
That's
know,
like
you
2 shows
did
in a
it,
row,
man.
right?
Well, there was a before when I was setting up. He was on my lap, or maybe in the pre-show. But he
No, I
was
thought like 2 weeks
not
ago he
during
showed up.
not during the main part. Anyway, continue
All right,
on.
Anyway, yes. So at this scale, our solar system, I guess, is still quantifiable, even it's lots of zeros in there.
Yeah,
But
we matter.
there is
still.
our Milky Way. So we have like a local bubble, if you will. Remember, our sun has a little local bubble, a little local area,
There's bubbles all
but
the way down.
made of galaxies. This one's called the galaxy group. And this is where our existential crisis truly begins.
Uh-oh, I love existential crisis. Let's go.
So from here, the larger structure kind of reminds me of the structural progress from planetary systems to the galaxy. So what seems big when you're a planet becomes very small on the galactic level, becomes very small at the galaxy group level. So if you, at this point, well, we'll see. So each galaxy is part of a group. Every single galaxy in existence out there is part of a group. More than 50% of them are part of the group. My goodness.
Are there any
I can't-
are there
sorry,
any
I wanna-
loners? Are there any loners?
Like what do you call those? Oh, what are those stars that don't belong to
Rogue?
rogue galaxies?
Yeah, rogue galaxies.
That'd be cool.
That would be
None that we
interesting.
know of.
Yeah.
So a group typically comprises of 50 galaxies, all gravitationally bound together. Right?
Okay. Mm-hmm.
So gravity still kind of rules at this point. That won't be the case later on, but right now it's still gravity for the win. In this case, we're in the local group, which is very clever in how we named it.
Come on, God.
What would you call it?
Let me think about it.
All right.
Well, in this case, it was named by Edwin Hubble, so take it up with him.
Okay. Well, yeah. I mean, you could be like the cool group, the hip group.
Oh, that'd be cool. Cool group, cool kids.
Yeah.
Cool
the
kids table?
cool kids.
They sit at
so
the back
it-
of the bus. They're all back there smoking on the back of the bus.
Greasers, the greaser
Right.
group.
So true to the definition, the local group has a little less than 50 objects, but it's really dominated by 3 structures. We have the Milky Way, we have Triangulum, And we have the Andromeda.
I was gonna say
galaxy.
Andromeda, which
And-
is gonna merge with us, and that will be an even bigger influence.
And what happens when Andromeda and Milky Way merge? What will it be called?
Pretty much. Oh. Well, that's just a merger, a galactic merger.
Right. What's the name of the new galaxy?
Milky
Milkdromeda? Milkdromeda!
There it is.
Yes.
Yeah. So Andromeda here is the main attraction, coming in at 1 trillion stars. So we might have 300 billion, probably 200 billion. So Andromeda's like 3 times the size of us. It's huge. And so like Liz is saying, these guys are coming in for a titanic iceberg collision and will eventually merge together into Andromeda in about 4 billion years.
Now, that collision, it's really not going to be a collision. They're just gonna pass right through each other, basically. It's like
because everything in space is so spread out.
Right, but
It's like when Grimer passes through Dan Aykroyd in Ghostbusters, go straight through him. Yeah. There's some stuff on them, but mostly go straight through them.
It's a good.
Yeah, so there's 1.3 stars in between the two. Less than 10, 20, 100 will hit each other.
But imagine those explosions.
Yeah.
Is that what it's like when worlds collide?
Hey.
All right, so in general, we have 4 very well-known groups. We have the local group, us, Stefan's Quintet, Robert's Quintet, and the Bullet group. And so Stefan's Quartet is
America
probably
name that
very
one?
well done.
American.
Yeah, so this would be a moment where I would put it up on the screen, but I didn't get pictures to Liz in time. They're very beautiful quintets in there for the local groups.
Yeah, just Google, quintet. Okay.
Hey, look at you go. Nice.
So professional.
All right, so that is the local group. Up next, we have clusters of galaxies. And at this point, clusters kind of become viewable at a massive cosmic scale. So, and this transition represents a major shift, both in scale and fundamental physics.
Oh boy.
So we had 50 galaxies in the local group, right? These clusters are made of hundreds to thousands of galaxies, each with billions of stars. So it's like, imagine, if you will, looking at a picture of the United States at night. So you have vast dark areas you'd see in the country, and then sudden clumps of lights with cities and the rivers of light that emanate from those city centers, right? Like whenever I'm on the planet night, I look down and it just reminds me of these kind of filaments that we see looking at the cities and the street lights.
Yeah.
And these clusters were first noticed in the 1700s by a friend of the show, Charles Messier.
Hey!
He listens every other Sunday.
Wow. He noticed. That's amazing that
In the 1700s.
in the 1700s you could notice galaxy clusters when we didn't even know what a galaxy was yet.
No. Yeah, because at this point, Messier really liked comets. Like, he just wanted to find all the comets. And so anything that wasn't a comet, he said, this isn't a comet, and he threw into a chart. And he was actually laying the groundwork for deep sky objects everywhere.
The Messier objects.
Marathons
Yes.
and
Yeah, star parties.
Astro
People do
nerds
like
everywhere.
marathons on how many you can get in a night, see in a night.
Yeah. So these individual galaxies, Milky Way, Andromeda, they are gravitationally bound, but that's not the major characteristic of this group. Hey, puppy, what you doing there? Only 1% of the total mass of these clusters are galaxies. So 9% of the mass is intergalactic gas, or the intercluster medium,
Oh, intercluster medium.
which is what we're calling a byproduct of Leia.
That's fair. And
Dude, sorry, he's just dropping toys and wants to play.
he's like, it's playtime.
Yeah. Boy, down.
God, see,
Okay.
it's
And we're back.
it's
Yeah,
you
we're
gotta
back.
have your children
So
at
that's
work with you. You know?
9% intergalactic gas, 1% is the galaxies, 90% of the stuff in this, dark matter.
Yes.
Which we don't know what it is. Check
Don't
out our
know
episode on
what it is.
episodes on
Is
dark matter.
wimps or
Wimps.
machos. Wimps.
Don't know what it
Williams.
is. So we have like the Coma cluster and the Virgo cluster, which is the closest, largest cluster to a local group. And the Virgo cluster is referred to as a rich cluster because it has a great number of galaxies.
Okay.
Core galaxies, like the Hercules cluster, which has many younger spiral galaxies, just has fewer galaxies out there. So you have rich clusters and poor clusters.
Wow, we really like to just divvy the whole universe up by wealth, don't we?
Yeah, cool. Capitalism, universal. Great.
All right, so those are the clusters. And now we have, ready for this, the step after clusters?
Oh, God.
Super clusters.
Of course, super clusters. Larger versions of the clusters.
And this is where I didn't read anymore.
Clusters upon clusters. Separated.
Clusters all the way down.
By clusters. Just clustering.
Wow. Ron's already said chickens all the way down. So we got to decide what
it's
is
always,
it chickens or clusters?
It's always chickens all the way down, but
so
it's fun.
Clusters.
But it's fun to make other things all the way down. But it's always at the end of the day and in our hearts, chickens all the way down.
Yes, indeed. All right. So for review, we have our Milky Way.
Yes.
1 galaxy.
Yeah.
We have a local group.
Yeah.
10 galaxies-ish.
Uh-huh.
A local cluster, 1,000 galaxies.
Yeah.
And now we have our supercluster, 47,000 galaxies.
Wow.
So our
guys, hold on. I'm just gonna interject here. It's just at this scale, and we're not even done with the scale.
No, we're not even halfway done.
Yeah. Okay. I just want you to then just think about statistically life in the universe. Not here. Well, here, obviously, but not visiting here, but life in the universe. Okay, continue on.
And we'll get there too. Don't you worry. Oh. So our supercluster is the Virgo supercluster.
Of course.
It contains 100 galaxy clusters. 100 galaxy clusters.
100 galaxy clusters when you have galaxy clusters of upwards of 47,000 galaxies.
Yes. And we're going to reference now another friend of the show, Sir William Herschel.
Good friend.
Never heard of him.
Very good friend. Very good friend.
See, when William Herschel was charting the sky, it was noticed that there were more nebulae, galaxies, but not at that time, in the constellation of Virgo than would be considered normal. Then in the 1950s, Gerard de Vaucluse supposed there was some kind of local super galaxy that they would all belong to, a super galaxy. And then in the 1980s, Brent Tolley, not the last time we'll hear him, then presented the structure of the Virgo superstructure, which is a flattened disk with a large halo.
Really?
And then, so that's our supercluster. Uh-huh. And then that same guy, Brent Tolley, went on to make the Virgo supercluster feel small. Oh. Because just 11 years ago in 2014, he, along with other colleagues, announced that the Virgo supercluster, the Hydra Centaurus supercluster, the Pavo Indos and Southern supercluster are mere arms of a much larger structure.
Wow.
Laniakea.
Oh, that's when it came out, 2014?
Mm-hmm. Which, if you are watching the show behind me, we have some strands of gold. That is Laniakea, and exactly what Liz is showing as well.
Oh, but if you can see the little dot, that's where we are.
There's Earth. Consider again that dot.
Yes, it's up there somewhere. Little red dot, right side.
Oh, sorry, Mitz. Oh, I leaned forward too much and made Winter leave.
There's over 100,000 galaxies in Laniakea, stretching across 520 million light years. So at the very beginning of the show, we checked on Major Photon.
Yeah.
He's been gone for 5 years. He's passed 2 stars. In 100,000 years, still not Laniakea. 500 million years, still had not passed Laniakea structure. That's how big this thing is. And we say at least 300 to 500 galaxy clusters in Laniakea because Laniakea, which I'd love to say, lies in the zone of avoidance.
Hey, so what is the zone of avoidance?
So the zone of avoidance, it's an area in the plane of the Milky Way where our telescopes are forced to look through all the gas and stuff all the gas stuff, stars, and it can't see through all that debris. So instead of seeing these rich galaxies all around us, we have zero idea.
Yes.
We got nothing.
Yeah, so if you see a map of the universe, you have all these galaxies that are out there and these strands and stuff, and then there's nothing. And that nothing corresponds to the plane of the Milky Way.
Now, realistically, that nothing, the universe is not, isotropic,
nothing.
but it's close enough to
That's
suggest what's probably there.
From.
Yeah,
Yes.
I mean, it's filled with galaxies. We just can't see them.
I think that's what the Vulcans are.
No, they're on their way.
They're
Thank
on
you.
their way. Oh,
Yeah.
Hopefully they
We
don't
still
show up
need it-
now.
We still need the Bell riots. We're a year late for that. Anyway. So in the zone of
They're
avoidance,
coming, Brandon. They're coming.
God, hold on. I just first of all, it's perfect sci-fi horror fodder, but
oh yes,
the real Mr. Proctor on chat. I made the most recent Desi map of the universe. Search up. Yes, the Desi map.
oh, that's so cool.
We talked about the most recent Desi map in one of our shot episodes, and then
Was it you?
or in one of our episodes, and then one of our shot episodes. Yes. Oh God, I think I saw on social you posted that you did that, but anyway, I'm just we get to this scale, and it's just so hard to think about.
Yeah, and I was reading about Desi for this show as well, for this episode. So that's really cool.
Yeah, so Brandon started the show talking about, like, it just blew his mind, and his brain melted down, and yeah, it's just, these are scales that we're not used to.
We cannot comprehend them because there's nothing.
Like, Brandon and I went to Prague last month, something like that, month and a half ago, whatever it was, and that was just the longest plane ride, and that's just, and it wasn't the company, because Brandon was sitting right next to me. It was just, it's a 10-hour flight, and you just start to I gotta get up and walk around, and like I can't go out the door. That's gonna get marshals shooting at me, but also it's a long drop. But and so that's just 10 hours away. We're not even talking this 520 million. These are just numbers we can't even comprehend.
Yeah.
And even like the galaxies in the universe, the number of those, and then you throw in the number of stars.
You basically you might as well just stop numbers. Just stop numbers.
Yeah.
Just stop them and just go lot.
And then really quick, to keep blowing our brains here, we have these thousands, 100,000 galaxies on Wildixia here, billions of stars within each galaxy, and then 2.2 planets on average for all of these stars and all of these galaxies, trillions upon trillions of planets. My God.
Beep boop, beep boop.
Right. So, we have that zone of avoidance, right?
Yeah.
Well, in the zone of avoidance is this
It's
area.
what every teenager puts between themselves and their parents.
What? What did you say?
It's what every teenager puts between themselves and their parents.
Yeah.
The zone of avoidance.
But within this is an area called the Great Attractor.
Hey, I'm out of drink. I gotta pour more drink.
Yeah, one more drink now. So the Great Attractor.
Mike hates.
Make it happen. I could go for another drink, but I'm on location, so I can't. Because I don't have it with me. Anyway, so the Great Attractor on Wildixia is where gravity comes to a centralized point containing 10 to the 16 solar masses, which is a lot of zeros.
Yeah. Well, 16 of them.
Oh my God.
Yeah.
Oh, hold on. I'm sorry. I thought of some things we didn't. Just let this percolate in your minds. Forget stars in the amount of galaxies there are. Black holes. Continue.
There are millions of black holes zipping around the galaxy. So when you look at a representative image of Wildixia, whether it's the image that Liz held up, or if you look behind me, all those golden strands and that as well, you can see, essentially rivers of gravity flowing to a single point, and that is the Great Attractor. Can you see it in my thing really quick?
I mean, we can see the directionality of them.
There it is.
Okay.
There's the Great Attractor.
That's where we're headed.
What? Wait, what's there?
Well, so let me say this.
It's gonna be like that Star Trek movie Star Trek movie where you break the barrier and it's just God.
Yeah. Which one was that? Was that 4? No, that was Undiscovered Country. That was 5. No, that was 5. Wasn't it 5?
It was one that sucked.
Oh yeah, you find God, and turns out God's a false prophet. Hey, wait a minute. So Laniakea isn't actually dense enough to be gravitationally bound. Like, one point of Laniakea is not gravitationally bound to the far other end of Laniakea, but the individual galaxy superclusters are anchored by that great attractor, which is still.
What references we did?
It was Star Trek.
Oh,
okay.
We're good with that. But even this great attractor is moving towards something else.
Oh, what's it moving towards?
The Shapely supercluster.
No, yeah, it was Star Trek. Ron. Anyway, sorry. Wait, say it again.
The Shapely supercluster.
It's Shapely.
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 Think about the Great Debate. Think about
Or
Harlow.
Shapley.
Shapley, sorry. Shapely,
Oh,
Shapley.
okay.
There
It's a
it is.
person's name. I was like, what shape are we? Is it an hourglass
Harlow,
figure? Are we talking a
probably
pear
from-
figure? Maybe an
yes.
apple? I don't know.
It's very
Great
shapely.
Debate.
Whatever it is.
This is the largest structure that's gravitationally bound. 10 times larger than Laniakea.
Hey, is there any coincidence that it looks like a brain?
We'll get there.
Okay.
We're going to get there.
It's a very shapely structure.
Shapely.
So here is a great quote that I enjoyed. Just as water flows within watersheds, galaxies flow within cosmic basins of attraction. That was Brent Tolley in 2014. And he says, galaxies flow within cosmic basins of attraction. So the rivers of gravity.
Said in a very Carl Sagan cadence.
Well, I mean, come on. I'm here. I gotta say it.
He's gotta be. I mean, wow. First of all, it sounded like the Pocahontas song.
It sounded like
a little
what?
bit. The Pocahontas song, like the Colors in the Wind song.
Colors of the Rainbow?
Mm-hmm.
No, my Colors of the Rainbow, my God.
Colors
Sorry,
of
Colors
the
of the Wind. You're right. I was thinking Skittles. I'm still on Skittles.
Skittles. Well, it's Skittles all the way down. Chickens and Skittles all the way down.
So that's Laniakea. That's those super clusters beyond it, 10
Skittles.
times larger. And we're still not done.
Oh my gosh!
Well, you got 1 minute, man, to pull this home.
We got, all right.
I'm just kidding.
Wait, we still don't know what's attracting everything, right?
A centralized point. Is like
Skittles.
not a berry center?
It like this? Is that the center of the universe then?
Skittles. It's a Skittle.
No.
Big Skittle.
There is not supposed to be a center of the universe.
There isn't. Everywhere's the center.
So why are all these things going to one place?
No.
Tracks with us now.
Just within Laniakea, not the universe in general.
Oh, okay.
Just this one structure, because there are many.
So maybe there's a
Laniakeans
larger
out
structure
there.
out there that it's moving towards because gravity
my
is
God. Welcome to
persistent
the-
everywhere. I made it.
Welcome to galactic walls or galactic filaments.
Okay.
So, the best way I can visually describe these is like looking at a brain's neural network. Remember, like all those PBS documentaries?
Yeah,
You
that
look at the
also
neural network
melts
of the
my brain.
With the lights flashing.
I'm
Yeah,
like,
the
my
lights
brain is
flashing
doing that shit
here
right
and there.
now. Is this what's happening? I mean, clearly not a lot is going off, but this is what's happening.
No, I think a lot is. It's just
Trying too hard.
can't comprehend it.
So the interconnected strands that connect the entire structure together like a spider's web.
My favorite thing.
So we're just going to look at a single wall, and I say for the sake of time,
the
and the notes
walls
I knew.
are the web filaments.
Yes.
Oh shit!
Exactly right.
This makes this okay. So I've just talked about like the like Hercules wall or there's something wall in one episode, but I didn't really in my mind get it, and now I get it.
It's the Hercules Corona Borealis Great Wall.
Yes. Okay. Oh. I like it when
Now,
science
this
clicks
great-
in my brain.
this
Can we
great
put, like,
wall.
a light bulb that goes off over your head?
See,
in
guys, what
post?
just happened?
Put it in post.
Liz gets a clue.
So this Great Wall is 10 billion light years in length. 10 billion light years
the
in length.
universe is 13 point whatever billion years old.
Right.
0.8.
But
Yeah.
the observable universe is 93 billion light years across.
Yeah.
Because the
Dark-
universe is expanded in
dark
those 13.8
energy
billion
and
years.
crazy.
Yeah. So this is like 11% of the observable universe. Just the observable universe,
But
mind
it's
you.
still 10 billion Light
I
years?
have a number for this. Give me a second. Hundreds, thousands, millions, billions,
it's
trillions.
60 million.
60 million
Trillion.
trillion miles.
Yes.
60 million trillion miles.
All right.
And
I'm just gonna
would
be here
walk
now, but
6
nothing's
million trillion
nothing.
miles, and I would walk 60 million
Nothing's
trillion
happening in my brain
more.
anymore. My brain just is done. I'm just gonna be here. This is what I am.
Well, yeah. I mean, this is great.
Brain melting. I told you. I warned you, Liz. I warned you.
There was the first thing that you said. Your brain melted going into with doing
I
this.
thought, and you know what? I mean, this happens just thinking about black holes, but now it's like,
Oh.
And black holes are the simplest things you pushed down on my.
I'm sorry.
Now, this structure, this Great Wall, was only discovered in 2014. And it was found by mapping 283 gamma ray bursts and using real fancy math. They found significant clustering that led to the creation of this new structure.
Oh my god. Guys, okay, I know we do this ad nauseum based on a fucking Planetarium show we saw, but horse and buggy days.
Yes.
But you know what? We're not fucking done yet, Liz.
Ha!
We got another step. If those filaments, if that Great Wall are the strands of the brain's network, the cosmic web is the whole enchilada.
Oh my god.
It is the structure of the universe. The gas, the dust, galaxies, dark matter, dogs, cats, Ron Proctor, everything lies in this cosmic web structure for the most part. But why this structure? Why is it
Hold on, I
cosmic
gotta
web?
pause you for a second. I just have to say, and if anybody, people who are in the planetarium field might get this, but the cosmic web in the planetarium is like one of my favorite visuals.
Yeah.
Ever. That purple.
Oh, I'm very familiar.
Cosmic web. Yeah.
In fact, if I had, let me do something stupid here.
Oh no, he's gonna break it.
I am gonna break something. If
break it.
I can get this working.
Break it.
Nope, not right now.
Okay. Don't worry about it. Oh,
I was gonna change my background.
Also, Jack on chat says that 10 billion light years, that's the distance a toddler can run if they have a non-food item in their mouth. And after working briefly in a preschool, I can concur.
Or they bite you and then they run.
Yes, I can also concur for that one as well.
All right, so why is the cosmic web a web and not like a dartboard, not like concentric circles or like a giant donut? Why is it a web shape? Why is it a web shape?
Why, Brandon?
Ongolia. So Ongolia came down, right? It was a mayor that really frightened.
Well, now we have to drink.
All right,
now we
man,
have to drink because you
had
went
this-
into the backstory a little bit there. You got excited.
But we had this discussion earlier. Do we include the Cimmerillion?
Oh, no. Okay.
Oh, shit.
I thought you meant just as his name of his drink, but if he wants to get all nerdy about it in the show, then yeah, we're going to drink for that.
Okay, no, I'm more than happy to take a drink.
So
but-
Tolkien Legendarium, not Lord of the Rings
All right,
specific.
there we go. So we have answered our
so-
question.
In the beginning, the density of the young universe barely varied at all. It was isotropic, homogeneous. It was smooth to a part of 1 in 100,000. So imagine, so here's how we're going to do this.
Okay.
You have a big Olympic-sized swimming pool, right?
Okay.
Or maybe not Olympic-sized. You have a big swimming pool. You take a can of soda pop, you open it, you pour it in there.
Okay.
That's the 1 in 100,000. That's how much it varied. Everything else was the same except for this one can of soda pop.
Fucking God. Or the kid that peed in the pool.
Given the kid that peed in the pool. So that's what we are. We are pee in the pool, folks. So given the scale of the universe and 14 billion years later, that tiny, tiny variance resulted in just enough change to create not a smooth cue ball, but a complex web structure. So as galaxies clump and come together, voids began to appear and gave birth to the structures that we see in the cosmic web today. And that's, you have billions upon billions of galaxies, trillions and trillions of planets. That is why you should not give a fuck and make art.
Or pee in a pool.
Or
Don't
pee in the pool.
Pee in the ocean.
We wouldn't have the universes that we have today if
Well,
someone didn't
the
pee in the
ocean-
fucking
God
pool.
damn, but that's a good point, Liz.
The ocean's one big toilet anyway. All the fish peeing in it.
So, from
Not to mention all the plankton.
by the
How
way,
much
you
plankton have we swallowed just being in the ocean?
Oh, don't. Okay.
A
But
couple.
anyway, if you want to see what Brandon was referring to, all you have to do is look up the cosmic background radiation image. And it's a beautiful
it?
picture.
Keep talking. Keep talking.
Reds and blues and stuff like that. And
Yes.
the reds and the blues refer to temperature differences.
Yeah.
But the temperature difference is really, when you look at the data, so entirely small. Like the temperature difference between the blue and the red, very small. They're very, very
It's
close.
contrasting colors, but it's
Yes.
not as
They're very
contrasting
close
as
to each
the
other in
actual-
temperature, and really, there it is right there. So,
Hey!
so if you're watching, here you
Did
can
I
see,
do it?
You did
Yep,
it.
you did it. So if you're watching, you can see the reds and the blues. The blue is colder. The red is actually a little bit warmer, but they're pretty much the same temperature right there. And the universe actually was very smooth, but that very slight, extremely slight, like
Variance.
variance, like not even
Mutation.
1%. It's like 1/100% in temperature, is what created all the structure that Brandon has talked about in the past hour.
And you know what? Go ahead. Go ahead.
No,
Take it home.
I was gonna say, from the from here on Earth to the Earth and Moon to the solar system to the Milky Way galaxy to the local group to all of these superclusters that are out there. That, what is behind Brandon right now, is what gave rise to all of that.
And not only is it behind me, it's going through everything right now. For example, if you have an AM radio station in your car, no one has bunny ears on the TV, but tune to
I
a
miss
channel
those
in your
days.
radio, right? Tune to a channel in radio that's just static. 1% of that static is the creation of the universe. So you can listen, in fact, to the creation of everything.
Yes, to the explosion that was the Big Bang, and the explosion's not the right word, but
And you know what? That may not be the end of the structures.
Hey,
What?
Brandon, should we talk about the multiverse?
Fuck no.
Hold on. I just want to say that this has all been very like poetic and beautiful, and all we got happening right on chat is that apparently whale poop is apparently very valuable, and my mom asked if people sell
Perfume.
it, and then Elizabeth says yes, and they sell it, and they really give a shit. So guys, whale poop markets.
God damn it.
And that we would not have whale poop if we did not have the C&B.
Hey, Brandon, bring it home, man. Bring it home.
My God. So we have structures upon structures upon structures in the universe, and we may not even be done. Mike alluded to the multiverse. We have weird string theory ideas, universes bumping into each other, weird waves that when they touch create big bangs for more structures. But this podcast structure is the main episode, followed by The Hangover.
I got some good questions for The Hangover coming up, if I can
Yes.
remember them when we get back to The Hangover, but I got some stuff.
You got some stuff.
So with that, follow us on all the things. I went to a protest yesterday. Hope you did too. Call your
We were in
representatives.
Nuremberg, but we were there in spirit.
That's what matters. Donate what you can. Volunteer what you can. We're in it for the long haul.
Fivecalls.org.
resist. Cheers, everybody.
See you in The Hangover.
Bye. If you're with us now, live, stick around. We'll be back for The Hangover.
God knows what. a while trying to get spotlights in the correct position onto me.
Yeah.
I spent like a good 15 minutes trying to get all spotlights exactly the pitch, the tilt, the zoom,
Yeah.
and ultimately I just turned them off.
Okay. Well, you're lit. Well, we're a little oversaturated, but you're lit. I'm lit well. So let me just say that Ron, being fully aware of the Blender software, I took your comment as I'm going live after the hangover making Easter eggs in Blender. My brain transferred it to in a Blender. So then I was just imagining you live blending Easter eggs in a Blender, which is a phenomenal visual. And then I see your following comment to my mom's question explaining that Blender is a free 3D animation software and he's showing how to make Easter eggs with the animation software makes a ton more sense. But I also would really like you to blend up some Easter eggs in a Blender.
Yes, Ron, some of us are more lit than others. And the crash is going to be
just
epic.
imagine the visual and you'll understand that yes, this is thanks for watching us instead of going live.
Also, so side note, yes. I recently made an Instagram account for Mr. Frodo.
Yes, follow
it's
Mr.
called
Frodo.
Mr. Frodo's Photos, all with F's. However, it's been suspended.
What?
Why?
I know.
Why has it been suspended? What'd you say?
Is it because Mr. Frodo kind of a thing that's like a copyright?
My activity doesn't follow community standards.
What if
You're posting dog
I
pictures?
don't know. So
Oh
I'm going to do that right now.
Okay, you do that.
I need 213.
Because that's a worthy follow. He'll social media his dog, but won't do this podcast. Anyway.
I don't know how to do the podcast.
Oh my god, I've given you so many directions. I've given you the log. Okay, Jack's here. Jack, hey, Chosen Family Easter luncheon went longer than expected. No, he just came in.
No, he did not. He was here in the actual episode.
No, he just says he'll have to rewatch the show.
I think if we go up in the chat, we'll see him.
I'm not gonna scroll up.
Anyway,
we're back.
Welcome.
Hey, welcome.
We didn't introduce. My account's been put back.
Yay, we didn't introduce.
Anyway.
Welcome
to Cosmos to Cosmos.
The Hangover.
Where we talk about politics.
The Hangover. No, I did have some questions. Okay.
The Hangout.
Okay, let's do it. Oh, wow. Mike just died, so now it's you and me, Liz, in the Hangout.
I didn't die.
Okay, so our main episode was about basically the structure of the universe. You know, I don't think a lot of people know, let alone think about that it's not just like our solar system that's in a galaxy, but the galaxy is in a cluster of galaxies that's in a super cluster of galaxies that's in this whole fucking cosmic is in a thing.
Like, what are those little Russian dolls?
It's a nesting doll of shit.
Well, yeah, but they have a name.
Nesting dolls.
Nesting dolls.
Russian nesting dolls.
Babushka dolls?
No, that's just like an old Russian woman.
That's the grandmama's.
Yeah.
No, it has a name.
No, it's a Russian nesting doll.
Nesting doll
I'm sure it does in Russian. Yeah, I don't know what the Vodka doll. I don't know. So then we started. Then at the end of the episode, it was a lot about. We had the Matroshka doll. Look at the vodka. Look at the Matroshka.
Oh,
and then you conquer the United States of America. Anyway,
from the inside.
It's the one kid that peed in the pool. So watch the main episode for that one. So Brandon got it. So okay, we have the structure of the universe, the cosmic web, and the cosmic background microwave. Microwave CMB. Background CMB that basically shows this
homogeneous.
No, it's not the same.
Isotropic.
No, the cosmic background don't
okay.
Get full body colors.
Okay. The little tiny temperature differences. And then that could just be another level of structure. And then my question was, do we need to like, we can't. Our brains are already melted. How many more questions do we need? Do we need to figure this out right now? Do we need to know the multi-universe thing? Do we need to
let's
think
not
about
do
string
that.
theory? Like,
Yes.
I'm just saying, like, my brain's
Yes.
melted. What is
Oh my
in
God.
the
All
what
right.
is the universe
You're
inside
talking
of?
larger, right? Like
So,
society.
yes.
We need to figure this out, right? Not
Yeah.
us in this podcast. 'Cause we
No,
won't.
we're not gonna figure this out.
no.
But
We don't
yes.
have the degrees or
But,
math skills.
although I do want to point out there was a guy in the 80s named Doug Forsett. Are you familiar with Doug Forsett?
No.
So Doug Forsett had the idea of how you get to the afterlife, and he made the proposition that it's based off a series of points. You do a good thing, you get plus points. You do a bad thing, you get minus points. And it turns out, if you get above a certain threshold, that's how you get into the good place. Watch The Good Place by Michael Schur. You know all about him.
It's a good. I've watched the first season.
Watch the rest.
Or the first. I know it's really good.
but yeah,
no,
to
oh
answer
no,
your
no, no. I'm
question.
sorry. My main. I'm trying to remember it after knowing I was gonna forget exactly what it was.
That's
but it
why
was
I
like,
asked you to
is
say-
it
ask
us
it.
saying things like string theory, which is obviously has no scientific proof behind it, so it's more of a philosophy
Right.
at this current stage of
Right.
development.
Yeah, okay.
Or multi-universe theory. Is this just like? Are we trying too hard? Like, is it
No.
just
No.
Are we just
absolutely not. We're
know.
following where the evidence leads us to. Some evidence suggests there should be something more. So of course
Okay.
people have to go dive into that and figure out what it is.
That's
Poke
why we
and
have
prod
the
and
ideas of the
suggest crazy
afterlife.
things.
There should be something more.
I think we're falling into the trap of there are hungry and unhoused people in the world. So therefore, why should we be worrying about this shit
No,
that,
no.
that we don't understand?
That's not.
Take a drink.
What?
Mr. Furlow dropped his toy down to the first floor.
Oh, okay.
I didn't know that was a drinking occasion, but
Buddy.
this is funny.
Oh, he's focused. This
So
might be an issue.
I think
Buddy.
He's gonna figure out how to scale down there.
we can do both. We can.
Oh, my thing wasn't like, why
No,
should
no,
we do
no,
this
I
when
know,
there's
I know.
world hunger? It was just.
I think I know you well enough to know that wasn't what it was.
Okay.
But you know,
Do you?
I
Are we
I
married?
do think that there is this argument now
Oh.
in the larger world, and we see
Uh-huh.
it with like NASA getting its budget cut and things like that.
Right, right,
We're
right.
not going to get into the politics of it all, but you know, it is like
Check out our episode on.
yeah, why
Funding
our
NASA,
shot
out now.
on? We have 2 shots on it, but why should we think about this when we have this going on? And I think we can do both. We can actually do both. And I think that understanding the temperature differences in the cosmic background radiation and how it leads to what we see in the universe today it advances humanity.
I just mean like maybe like the people thinking about what universe is slamming into each other. Like maybe they should spend harder time on figuring out like how physics doesn't break down once we get to a certain point to make the other things.
But it's also up to the individual. Like for example, I am terrible at math. I am terrible at physics.
Are you? I am
Right,
amazing
right.
at math.
Yeah.
Have you seen me do math?
Oh, that's right. She does math. I suck at physics. But
Right.
Check out our
okay,
third main
but-
episode where Liz
but-
fails at math.
Given that we are both terrible at math and physics, we can still talk about math and physics to other people who, like us, do not understand it. So somebody can be listening to us and say, hey, you're talking about the structure of the universe, you're talking about these galactic scales and equations. Why don't you go research that? Because that's not what we do.
Right.
That's not what we do. That's not what we like. That's not what we're interested in. That's not what we're
I'll
good
tell
at.
the jokes. You do the
Right.
hypothesizing.
So it's the same thing within physics, like the particle physics and the galactic physics. They're different interests, they're different knowledge bases. You can't say change your
Okay,
whole life to
follow-up
pick
question.
what I think.
Follow-up
Right, sorry.
question.
Hold on. I do want to say one thing.
Okay.
Because you mentioned physics breaking down.
Yes.
Okay. I do want to say.
At 13 to the negative 32.
Right.
10
Well,
to the
no,
negative
no,
32.
No,
Whatever.
I do want to say this. And physics does not break down. Our understanding of physics breaks down.
Right. Oh.
And I realize that that's a very subtle difference.
It's a
no. In the larger world, that is a very subtle difference.
Because again, horse and buggy days, we don't know shit.
No, we don't know shit. Yeah, Brandon, go ahead.
I just had a conversation about this the other day. But do you think that we create math and physics, or we discover math?
Oh, we
physics?
Discover completely.
Same page.
It is discover. We don't make it.
Liz, live that for a moment. What are your thought process
I don't know.
about
That's
that?
an interesting thing.
It's
because,
a very interesting question.
Do we create or discover?
I would.
We discover.
Well,
I agree.
I think we create how we use it. Because if you
but that's engineering.
No. I'm just thinking about like if there happens to be
down with the people's elbow.
If there it's a fucking rock reference.
It's a WrestleMania today.
Oh, okay. Wow. Anyway,
that's why I'm here.
Oh, that's right. No, I'm just thinking that. So, fuck. Don't let me lose it.
Focus.
Okay, so like an alien civilization, whatever light years away, would have different. They would maybe see it differently, or like, how do we know how they're doing? I guess their numbers would be different, but
C is different, but fundamentally, whatever
but
the numbers they use based what.
Okay. But again, we only have this limited window of technology and.
Correct.
And we're seeing things
would
that
you say
prove Einstein or prove these things.
Would you say that we're in the horse and buggy age?
Yes.
Oh, she said that a couple times.
How do we know that, like, maybe, I don't know, like at some point it's not breaking, I don't know. Like, I don't know. It's like,
I don't know. In the chat, there was a good moment. Do we discover or misunderstand?
Yeah.
That's
a big fucking question.
Yes.
How much of what we know do we not actually know?
All right. Can I just say stuff?
Yes, you
for
can.
A second?
Absolutely not.
Math is the language of the universe. It's the language of the universe, and
says the math guy. Bias.
Just like how we say things differently than, say, people in Italy or Germany or wherever.
Ich liebe dich. But
I love you too.
but I'm just saying.
Though it sounds like you're gonna murder me.
No, my only point, and I'm not saying you're wrong. You're definitely going to be right.
No.
My only count, my devil's advocate, which I'm not known for playing because I'm not good at arguing.
Let's do it.
Arguing, is we're saying all of this from our own earthbound human and life data point sample perspective that we maybe don't, and our the technology that we have so far, like that there's, we don't know.
Right.
Yeah, we're limited by our biology.
Right. No.
True.
Okay. We're limited by the tools. We're limited by the tools. We are also, yes, I mean, the brain is a tool. But think about this. All right, so the Earth, let's just say, speaks English. I can pick another language. Let's say Italian. We have the translators, the universal translators.
There's a great book series I can suggest after this.
Yeah, it's called Math. How we describe like something in math is like this is how we write down math in our language.
You said the Earth speaks English,
right?
So I'm saying we have universal translators. Let's make it something else.
Alpha Centauri has a planet, approximately whatever, one of those fucking stars.
One of them, yeah.
And
there's planets everywhere.
Let's say they have life there. Oh, whatever that.
Oh,
fucking
that one
was.
With the biosignature detected.
K218b.
100 and something light years away, or whatever.
Topic of the next episode.
Yes, high in the sky. It will be in there.
K218b is a planet that James Webb looked at. It has biomarkers. Mm-hmm. Some of those biomarkers could be explained without life, and so whatever. Look it up. It's online. Look it up. Anyway, let's say that there is life there, intelligent life.
Oh, that's a stretch. I thought.
Yeah, and so they come up with their version of calculus and stuff like that. It still is the language of the universe. And even though we use different, squiggly lines and things like that, it's still, the two are still, you can translate one from the other. It's like translating English to Italian or to Spanish or whatever.
Yeah, but sometimes we make those say what we want. How do we know? How do we know?
Oh, Federico's with us.
Hey, is that your BP?
Hey.
How do we know we're not just like in our echo chamber of our own science?
Hey, you know what?
Okay, and that's
a
the
real thing.
point.
That's
Yeah.
a real thing. That is a real thing. People
Like creationists?
well,
that's
no,
not science.
No, I will say there are scientists that do the same thing. It is not just creationists that live in an echo chamber. The thing is, and we have said this many times.
Brandon's excited.
Mike's on the line. I'll follow him.
Okay, we have said this many times that there's a certain age that you hit that you are more likely to fundamentally change whatever field you're in, and it's something like 30. It's that age is 30, and
Oh shit!
and
Oh shit!
Welcome.
and what happens
Oh,
is,
well beyond that.
and what happens is you get up to, you are malleable. Up to the age
Nice
of
word.
30, you're malleable to coming up with new ideas, and then and then you get to a point where you
get
start
more
to believe
Republican.
your shit.
No, that's not true anymore. Is that why? Like, what's the average age that the Nobel laureate comes up with their idea? Comes up with their
like,
principle, like
28.
27, 26?
Makes sense.
Yeah.
I mean, your brain is 25 is when your brain's like, hey, I can figure shit out now.
Right, but no, it's like the age of 28. You are willing to accept where it takes you.
Yeah.
And then you pass 28.
Yeah, because your body
30.
starts hurting, and you're
Yes.
like, I don't have the
But-
energy for this shit.
But you start to believe that
Yeah.
you're the shit, and
Hell yeah, I'm the shit. I've gone through all this shit. I've done all these things. I'm the fucking shit.
And so it's yeah, and so
The problem is that just as humans, we don't have the energy by this point to care. So we're like, we're just in it for what we're in.
I think they all care. It's just that what happens is it's like it's like the older
like
generation
concrete
that
setting.
listens to Fox News, quote unquote news, and they think that is the reality. And so what happens is that these scientists they see the data and they look through it with rose-colored glasses,
Einstein?
and they try to make that data fit into their paradigm.
Einstein, his greatest blunder,
But
he was
at
stuck
the
in his
same-
own shit.
Yeah,
But at the
exactly.
same but at
Einstein's
the,
a perfect
but at the
example.
same time, like as you become more knowledgeable, like you accept that the ideas you had no longer pertain to the universe.
Well-
and but let me continue on my track for a second.
Yeah.
Yeah, you had
So
time.
yes, you are set in the way in one respect, but also you're knowledgeable to understand your own ignorance. Like you don't understand your ignorance when you're 25. You think you know everything, right?
So true.
And you're 35, 45. You understand. It turns out you don't know shit. But
Yeah.
somehow the ideas that you're having are still obtained in your 20s in that decade. So it's a weird dichotomy of understanding you don't know, that you fully accept that you no longer know everything. I hate to. So it's like a Neil Tyson quote: "As your area of knowledge increases, the perimeter of your ignorance increases." It's the same idea. You understand that at a certain age, but somehow you can't break through that.
Right. And but
So,
also
yeah.
but also I think we're talking about highly smart people. Yeah, exactly. It's called the Dunning-Kruger effect.
Oh, bingo. Yeah.
And so we're highly intelligent people. And we're talking about some of the smartest people in the world.
The smart people, not us.
And we have said like numerous times, that there is a moment where a scientist is the only person in the world that
My favorite moments.
knows what they know, and nobody else in the universe knows it. And like Einstein,
you can't say universe.
No. Well,
No.
okay. Nobody else in the world. You're right.
In the
Nobody
known
else in-
universe.
Well, there you go.
No, because we know a lot of the universe. We know a percentage of the universe, but we don't
know of intelligent life.
Yeah, but it's probably in areas that we do know about.
All right. Anyway,
But we don't know it. Welcome to semantics.
yeah, and so the problem
Press the
is
further. Sorry, he was chewing on a power cable.
Oh.
Damn. No, sir.
It's like a cat.
that would be so funny if the LED dome just went out. Well, so much for the WWE tonight.
Anyone?
Guess that ring didn't make it to Mordor.
Hiring position because I need a job. Buddy.
Bigfoot astronomy. All right. Anyway, we're not hiring anybody.
No.
All right.
Dragons.
No, but even Einstein, as smart as he was, started to believe his fucking shit.
Yeah, you get,
But it was wrong. And you do, yeah. So Brandon brings up, the question, do you realize that you don't know what you don't know? And I would say the answer for most people is no.
I don't know
because we don't want to admit that. We don't want to admit that.
I don't know a lot of things.
And if we can take this to the further existential crisis that was, because I do need to be out of here very soon.
Oh, okay.
There's a great quote by the Flaming Lips.
Oh.
And it is Mike spurred
the philosophers of our time.
The philosophers of our time. They have a road in Oklahoma City. Anyway, so Mike mentioned, do you realize? And so talking about the galaxy, the cluster, the supercluster, Laniakea, the cosmic web. But ultimately, it brings me comfort knowing that every dot behind me, by the way, is a galaxy with 300 billion stars, with 2 planets. There are trillions and trillions of planets behind me. But to take this into perspective, we're not talking about billions of years or millions of years in the expansion of the dark matter, dark energy. But it is, as the Flaming Lip said, do you realize that everyone you know someday will die? and so this is why I said in the main episode, fuck it. Do art. Do what you love. Reach out to those people. Hang out. Make stupid podcasts. Make what you want. Be comfortable. Have dogs. Because God damn it. Us in the speck of a cosmic ocean, a cosmic tidal wave is nothing. But to us individuals, to the dogs, to Winter, to the cats out there, we're everything. Mm-hmm. So, God damn it, enjoy life. And that means within your lifetime, you can still make a difference by calling your representatives, by protesting. Make a goddamn difference. Because this is not a sprint at this point. It is a marathon. Sign these petitions. Volunteer. Because we love space. We love the universe, planets, galactic rays, black holes. It's all great. Mm-hmm. But that's because we love life. And that's what we're here for. So with that, ladies and gentlemen, follow us in all things.
Yes.
Yes. Get tattoos. Enjoy your life. Get pets. Fuck shit up. Have fun.
Cheers, everybody.
We'll see you next time.
Bye.
Bye.
That was beautiful. I gotta lean over now to close it out. We're still on, but that was amazing. So bye, everybody.
Yes, beautifully said. Katie says beautifully said.
Yes.
Congratulations, Katie.
Bye.
Oh my God, congratulations, Katie.